Hey folks, welcome to 1.7b. I can solve one variable equations mentally. Tonight we've got some review action. Of course you have your video work, 4-blocker, and then a little practice here. Let's get going with the pink review. Take no more than 5 minutes to do this order of operations problem and write two equations to represent these two situations here. Go ahead and pause it.
Okie dokie.
Order of operations, got to do parentheses first. Have to do exponents. 6 times 6 is 36, not 12. 10 divided by 2 is 5. 36 plus 5, 41. Jim walked 2 miles on Monday. Some more miles on Tuesday. He walked a total of 5 miles. I had some money. I gave $2 to Britt. $5 left. All right, tonight you will be solving these equations mentally. It means no calculator involved. They're really pretty straightforward and simple, but it'll also be a great opportunity to review how to write one variable equations, the target we did right before this. So you'll be doing a little bit of both. Good luck. Have fun with the video. Hey Valley Metal, welcome back to another math video. Tonight we're going to be solving one variable equations mentally. Let's start off with our trivia question. Who sang Sweet Caroline? Well, I'll be back with the answer to that question after instruction. Tonight officially our target is I can solve one variable equations mentally. Let's do this thing. There are 25 apples in the barrel at the beginning of the day. At the end of the day there was only 5 apples left. How many apples were removed from the barrel over the course of the day? Now, most of you are just going to go, well, 25 minus 5 is 20, and that's fine. I'm going to encourage you tonight to think about the kind of equations that we were writing last night just for a little additional practice. So I would think about this as 25 apples minus some apples is 5, so 25 minus 5. Oh, it's got to be 20. Or the apples that were taken plus the 5 they have left would equal 25, so it's got to be 20. Just getting to think about writing them as we solve these, just to get a little bit more practice, because 1.7a, the target before this, writing those one variable equations is challenging. Not too much to learn in terms of vocabulary tonight, just a review of equation, two expressions separated by an equal sign. A variable, a letter stands for a value. Here's an example of an equation, 3m equals 6. This is an expression, just 3m, no equal sign. This one here we could solve. We could think 3 times something equals 6. 3 times something. 3 times 2. 3 times 2 equals 6. Yes, I solved it. Now you know how I got to be such a cool math teacher. I'm lickety-split on my basic facts. All right. Here's a little story about the Plinka family. All 3 Plinka kids went trick-or-treating last Halloween. Poppy got 175 pieces of candy. Holiday got 225 pieces. They got 407 pieces altogether. How many pieces did Mrs. Plinka get? Yeah, I know I said 3 kids. I'm 100% serious. All right, so let's think about this, solving this mentally. If Poppy got 175 pieces and Holiday got 225, that's 400 altogether. So 400 plus, well, 7. Mrs. Plinka must have found on the ground 7 half-eaten pieces of candy, and she's claiming them. She never quite grew up right. Right. Let's take a look at another question. Then I'll turn you loose. Mrs. Crothers brought me 3 super nice birthday presents that all cost the same price. If she spent $150 altogether, how much did each gift cost? Most of you are thinking about it, thinking, what would it be? I'm not sure. Well, let's take a look here. 3 presents equals $150. There they are. They're the 3 presents. There's the total cost. So what would that be? 3 times something is 150. 3 times 50. She spent $50 a piece on each of the gifts. Okay? All right. See how you do. Here's 2 quick problems. Try them on your own. Go ahead. Let's see how you do. Well, here's the pennies in his collection. If you divide them by 10, there's 18 in total rows. So pennies divided by 10 per row, 18 rows. 180 pennies. What would be 180 divided by 10? You could just multiply these 2 numbers together, kind of reversing operations. All right, here's another one. Mr. Persons ate 52 pancakes at the IHOP last Sunday. A new indoor record for Apple Valley. His personal best is 65 pancakes. How many more pancakes would he have had to eat to tie his personal record? Go ahead and see if you can solve it. See if you can think about the equation now that you've solved it. All right, let's take a quick peek. Well, here's the 65. That's his personal best. And that's going to be equal to last Sunday's plus how many more pancakes to tie? Well, if I eat 10 more, it would be 62. So there's got to be 3 more after that. So 13 more pancakes to tie. The target is just that simple, folks. It's so easy. I know I can get you to do a little extra practice writing equations. Go ahead and take a look at these two right here. I started the year with 100 pencils. Mrs. Carlton gave me some more. Now I have 132 pencils. How many did Mrs. Carlton give me? Next question. Mr. Hawkinson had 45 coins in a jar. He gave a handful to his kids to play with. Now he has only 15 coins. How many coins did he give his kids to play with? All right. Here's the answer to the trivia question, my friends. Sweet Caroline was sang by Neil Diamond. It was released in 1969. A lot of people often wondering, where did this song come from? What's it about? Well, he told, and I think it was 2007 in an interview, he said he saw JFK's daughter Caroline and a picture of her riding a horse, I believe, and he was inspired by that picture to write Sweet Caroline. Well, then in the later interview, maybe 15 years later something, he said it was about the song was written about his wife, and her name was Marcia. But he didn't use Marcia because he needed a 3-syllable name to go with Sweet Caroline. I guess it doesn't sound right. Sweet Marcia. I'm going to go with Sweet Caroline on this one. Sorry, Marcia. All right, see you later. Hey folks, welcome back. Hopefully you got your video work done, your pause problems, your ticket to the show, and you learn a little bit about Neil Diamond along the way. All right, here we go. Let's do just a quick review. We're going to be solving for g or whatever variable it happens to be. In this case here, we've got g plus 2 equals 3, so we can figure out mentally that that's just 1 plus 2, so g is equal to 1. A couple others. R minus 2 is 4. Well, you can kind of think about that, turn around that backwards. If something minus 2 is 4, then 4 plus something equals that number. So 4 plus 2 is 6, so 6 minus 2 equals 4. Little strategy, I worked it out, I solved it that way. 4d equals 12. Well, let's think about that. Let's think here. So 4d, so 4 times something is 12. Well, that could be 4 times 3 is 12. I know that's a basic fact. So, all right. So we've got to remember that whatever we've got on one side of the equal sign has to be equal to the other. That's why 4 times 3 has to be the answer. That's the only thing that d could be. Nothing else is going to work. In the same way with this one. That's why I just lined them up right above the equal sign. Just keep that in mind. Think of that as a balancing point. 3 ways to solve these problems. You can talk it out like I did over here a little bit. I talked it out. You can actually solve it and go, well, 4 times something is 12, so 12 divided by 4. That's kind of solving it. I did that here. I kind of went, well, 4 plus 2 has got to be 6. Well, the other thing you can do is sometimes you've got multiple choice answers, and you can just take and sub in all the answers and figure it out. So let's take a look at how I might do that. 6 different problems with 2 of each. This one here, the K's stand for, these are just ones that I just know, and I just can just put the answers in and work it out. So this one here, something plus 5 equals 14, so it's got to be 9 plus 5. So I just kind of talk it out in my head, and I know how to solve that one. Here's another one. 63 equals 9 times something. 9 times 7. All right. Did you notice how I did that? I didn't say 63 equals 9g. I said 63 equals 9 times something. Up here I said something plus 5 equals 14. I think saying the word something instead of a variable on these types of equations really helps kids solve. So there's a couple that you can just kind of talk yourself through. Here's a couple examples of substituting, of solving it. On this one here, a little bit harder here. Something plus 18 is 59. Well, I don't know it off the top of my head, but I could think, well, 59 minus 18, I could kind of figure that out, that 58 minus 18 is going to be 40, and they got that 1 extra there, so 41 plus 18. Then I can think about it this way, too. I can think, well, 40 plus 10 would be 50, and here's the 9, okay? So that's solving it mentally. Here's another example of that. 10 equals something divided by 4. Well, and you just kind of start thinking about it. Well, what if something divided by 4 is 10, that means that 4 times 10 would be this. So 4 times 10 is 40. So let me try that. 40 divided by 4 equals 10. So again, you're still talking itself through, but you're actually kind of solving and maybe reversing the operation. Take a look at these two down here. Number 16. These are examples of ones that I wouldn't know right off the top of my head. And so I would look at the answers and see which answer makes the most sense. And then once I've got the answer, I would think about these two here. This is a subtraction problem. 12 minus 5.6 equals 7.0. So these two together have to equal that. Well, 7 plus 5 is 12, and there's your 0.6. See how I worked backwards? Got the answer that was close, and then just double checked it. Same thing here. Something plus 13.5 equals 16.0. Well, this answer looked like it was about right, so let me just check it. Here, 2 plus 13 is 15, and then I got a half plus a half. There's my 16. So these are a couple of examples of how I would like you to show your work as well as work through these. And you can do a combination of any of them that you want. You certainly don't need to label how you do it. But when you work through your independent practice problems and your 4-blocker today, cross off the variable, put the answer in. That's what I'm requiring. Okay, let's try it quick on this 4-blocker here. I want you to pause it and work through these 4 problems. All right. Make sure you showed your work something like this. Cross the variable out. Notice how it's next to this, so I'm putting it in parentheses. So 3 times 4 is 12. Same thing here. 2 times 2 is 4. Plus 1 is 5. That's kind of tricky. Did you get that one? Yeah, we had the plus 1 on there. Okay, 20 divided by 4 is 5. Just cross off the variable there. Same thing here. Cross off the variable and put the answer above it. All right. Sounds good. Well, I think you are ready for your independent practice. I'm just going to have you do problems 1 through 24 here. And I'd like you to do those. You can do them 3 ways. You put them in your notebook. You can put this sheet into Notability if you'd like. Or you can print it out. No matter how you do it, you'll end up whichever these ways, you just make sure you get your work done quickly. Make sure that you copy the problem down, cross off the variable the way I showed you before. And then if you put it into Notability or if you print it out, then please take and upload that along with your other page, your video work, your review and such. Okay? Alrighty then, let me just make these bigger and I'll let you take a look at them. 1 through 9. 7 through 18. There's the rest. Now, if you wanted to put it into Notability, I will have attached a PDF to this assignment. You can print it out from that PDF as well. All right. Thanks a lot for listening. I appreciate it. Have a great day. Good luck in your quiz.